வாய்ஸ் கேட்குதுங்களாம்மா? வாய்ஸ் கேட்குதுல்ல? சார் குட் ஆஃப்டர்நூன் சார்.
Sir, good afternoon, sir.
வெல்கம் சார். வெல்கம் ப்ரொஃபஸர். உங்கள் வாய்ஸ் கேட்குதுங்களா உங்களுக்கு?
Okay, you could able to hear me now?
ரைட் நவ் இஸ் ஏபிள் சார்.
It's able, no? Okay. Yeah, that's
Few
fine.
minutes, Professor. HODs and the other
Okay.
directors is joined, sir. Will join, sir.
I see. Okay. Okay. Good afternoon. இது என்னோட இது போய் பிபிடி ஒரு செக் பண்ணிக்கலாமா இல்லை அப்படி வேணாம்? ஹலோ, பிபிடி ஒரு செக் பண்ணிக்கலாமா இல்லை வேணாமா?
பிபிடிங்களா சார்? செக் பண்ணிக்கலாங்க சார்.
Can I click it?
Okay, sir. Presenting portions, sir.
I want to go for presenting.
Okay, sir.
Where I will go. Everyone. Show everyone your need is fine.
Right, corner present now option is there.
Present now அந்த ஆப்ஷன் கிளிக் பண்ணவா?
Yes, sir.
Okay. Window. இல்லை இது இவர் என்டர் ஸ்க்ரீனா விண்டோ?
Entire screen is very useful, sir.
I have PPT plus ஒரு PDF file வந்து I have with me.
அப்போ டோட்டலாக என்டையர் ஸ்க்ரீமே கொடுங்க சார்.
அப்படியா? ஓகே.
கிளிக் பண்ணிட்டு இவர் என்டையர் ஸ்க்ரீன் கொடுத்தா நீங்கள் எல்லாத்தையும் ப்ரெசென்டேஷன் பண்ணிக்கலாங்க சார். எது மினிமைஸ் பண்ணிட்டு எது போகணுமோ அது வந்துடுங்க சார். நோ ப்ராப்ளம் சார்.
ஓகே. பட் இதில் வந்துட்டு இப்போ பட் வாட் அபவுட் மை PDF and other files section? Can you able to see anything on this,
No, sir. இல்லைங்க சார். No presentation for your side, professor.
ஓகே, நான் என்ன பண்ணுறது இப்போ? எது கிளிக் பண்ணலாம்
சார்? ப்ரெசென்ட் நவுன்னு ஒன்று ஆப்ஷன்ஸ் இருக்குங்க சார்.
பண்ணிட்டேன் நான்.
அதை கொடுத்தோன்னா என்டையர் ஸ்கீம்னு வருங்க சார். அதுக்கு முன்னாடி நீங்கள் என்ன பண்ணீங்க சார்? எல்லா ஃபைலும் ஓப்பன் பண்ணி வச்சுங்க சார். பிபிடி
நான் ஓப்பன் பண்ணி வச்சிட்டேன் நான்.
ஓகே சார்.
ஆல்ரெடி ஓப்பன் டேட். இப்போ வந்து மீட்டிங் டீடைல்ஸ் ஐ ஹாவ் டேன் ஆன் கேப்ஷன்ஸ், ரைஸ் ஹேண்ட், சம்திங் இஸ் தேர். வேற ஒன்றும் இல்லையே. மீட்டிங் டீடைல்ஸ் நவ் ஐ ஹவ் டு ஒரு நிமிஷம். எது மீட்டிங் டீடைல்ஸ் செலக்ட் பண்ணுமா இல்லை எப்படி?
என்னங்க சார்?
இல்லை இப்போ வந்து ஐ ஹவ் டு ஷேர் வந்து நான் சப்போஸ் கிளிக் பண்ணுமா இப்போ?
ஆமாங்க சார். ஜஸ்ட்டு ப்ரெசன்டேஷன் இடத்துல நீங்கள் அதை ஷேர் பண்ண முடியுங்க சார். ரைட் கிளிக்கு என்டையர் ஸ்க்ரீன், யுவர் என்டையர் ஸ்க்ரீன் சார். அப்புறம் நீங்கள் அதை வந்து கிளிக் பண்ணால் டைரெக்டாக போயிருங்க சார்.
ஷேர் ஆப்ஷன் ரைட் கிளிக்
ஸ்க்ரீன் சார். அப்புறம் நீங்கள் அதை வந்து கிளிக் பண்ணால் டைரெக்டாக போயிருங்க சார்.
Share option. Okay, one second. I will right click and go. Nothing is coming. Okay, 1 minute. I'll just. Okay, present now வந்து நான் கிளிக் பண்றேன் சரிங்களா?
ப்ரெசன்ட் now. ஓகே
ஓகே, அதுக்கப்புறம் வந்துட்டு தென் யூ ஹேர் என்டையர் ஸ்க்ரீன் இருக்குது, விண்டோ இருக்குது.
என்டையர் ஸ்கிரீன், யுவர் என்டையர் ஸ்கிரீன் சார்.
ஓகே சார், நான் பண்றேன்னா பட் எனக்கு வேற ஏதோ
என்டையர் ஸ்கிரீன் கிளிக் பண்ணிட்டுங்க சார். நீங்கள் அந்த எந்த ஃபைலை ப்ரெசன்டேஷன் பண்ண அதை வந்து ஸ்க்ரீனில் வையுங்க சார்.
ஓகே
என்டையர் ஸ்க்ரீனை கிளிக் பண்ணிட்டுங்க சார். எந்த ஃபைலை ப்ரெசன்டேஷன் பண்ணுங்க அதை வந்து அப்படியே நம்ம சிஸ்டத்துக்கு முன்னாடி வையுங்க சார்.
இப்போ தெரியுதா அது வருதா இல்லையா?
ம்
இல்லை இல்லை, இப்போ பிபிடி வருதா?
இல்லைங்க சார், லோடு ஆகலைங்க சார்.
லோடெல்லாம்
ம்
ஐ டோன்ட் நோ வாட் இஸ் ப்ராப்ளம்.
ஜஸ்ட் நான் ஒரு ஸ்க்ரீன் பண்ணுற பாருங்க சார். இப்போ என்டையர் ஸ்க்ரீன் கொடுத்துட்டேங்க சார். ஷேர்னு ஒரு ஆப்ஷன் வருதுங்க சார்.
எனக்கு ஷேர் ஆப்ஷன் இல்லையே.
இல்லைங்க சார், இப்போ என்னங்க சார், இப்போ அந்த ப்ரெசன்டேஷன் நவுன்னு கொடுங்க சார்.
ஒரு நிமிஷம்.
ஒவ்வொரு என்டையர் ஸ்க்ரீன் வருதுங்களா சார்? அந்த ஒரு இமேஜ் காமிக்குதுங்களா சார்? ஷேர் யுவர் என்டையர் ஸ்க்ரீன் இருக்கு, அதுக்கு மேலே கிளிக் பண்ணுங்க சார். அதுக்கு மேலே கிளிக் பண்ணுங்க சார்.
ஒரு நிமிஷம். ப்ரெசன்ட் நவ் ஐ வில் கிளிக் ரைட். ஓகே,
ம்
ஒரு என்டையர் ஸ்க்ரீன் இருக்கு, நான் கிளிக் பண்ணவா?
கிளிக் பண்ணுங்க சார். யுவர் என்டையர் ஸ்க்ரீன் கிளிக் பண்ணுங்க சார்.
சரி, இல்லை இப்போ வந்துட்டு என்டையர் கிளிக் பண்ண வந்து என்னோட வந்து இப்போ வந்து இருக்கிறது வந்து என்னுடைய இது வீடியோ கேமரா அந்த இது இருக்குது, அந்த இது என்னுடைய பிக்சர் இருக்குது, ப்ளஸ் வந்து பார்ட்டிசிபென்ட்ஸ் ஒரு 6-7 பீப்புளோட இது வந்து இருக்குது, ஐடிஸ் அந்த ஃபோட்டோஸ்.
ஓகே சார். இப்போ வந்துங்க சார், என்டையர் ப்ரெசன்ட் நவ் கொடுத்த பின்னாடிங்க சார், இப்போ ப்ரெசன்ட் நவ் கொடுங்க சார். ப்ரெசன்ட் நவ்னு கொடுத்த உடனேங்க சார், யுவர் என்டையர் ஸ்க்ரீன் வருதுங்களா சார்? அதில் வந்து பார்த்தீங்கன்னா ஷேர் யுவர் என்டையர் ஸ்க்ரீன் ஒன்று ஒரு ஆப்ஷன் காமிக்குங்களா சார்?
பட் இப்போ எனக்கு வந்து இந்த ஸ்க்ரீன் தான் வருது. இப்போ என்னோட ஸ்க்ரீனில் இப்போ இது வந்து இருக்குது ரைட் நவ், இதான் இருக்குது இல்லையா? அதுதான்.
ஓகே சார்.
ஸோ ஐ வில் கோ ஃபார் மேபி shall I go here now?
இப்போ பாருங்க சார், இப்போ நான் பாருங்க டைரெக்டாக என்டையர் ஸ்க்ரீன் கொடுத்தாங்க சார். அப்புறம் யுவர் ப்ரெசன்டேஷன் ஸ்க்ரீன் வந்துச்சுங்க சார். அப்படியே போயிடுச்சு ஜஸ்ட்டுங்க சார்.
நீங்கள் ஏதோ பண்ணுறீங்க, யூ ஆர் ப்ரெசென்டிங் டு எவ்ரி ஒன், அது பண்ணுறீங்களா?
இப்போ வந்து முடிஞ்சு. இப்போ நான் க்ளோஸ் பண்ணுறேங்க சார். இப்போ உங்களுக்கு நீங்கள் ப்ரெசென்ட் பண்ணால் நான் ஸ்டாப் பண்ணுறேங்க சார்.
சரி, க்ளோஸ் பண்ணிட்டீங்க. ஓகே,
இப்போ நான் ஸ்டாப் பண்ணிக்கிறேங்க சார். இப்போ நீங்கள் அதே மாதிரி ஆப்ஷன்ஸ் பண்ணுங்க சார்.
என்டர் ஸ்க்ரீன் கிளிக் பண்ணட்டா?
கிளிக் பண்ணுங்க சார்.
சரி, ஓகே. எனக்கு வந்துட்டு இந்த ஸ்க்ரீன் தான் வருது. இந்த ஸ்க்ரீன் யார் ஜாயின் பண்ணியிருக்காங்க என்னுடைய அந்த இதுதான் வருது.
ஓகே சார். மற்றது எது வரலைங்களா சார்?
வரல. ஏன் அப்படி? வேற ஏதாவது பண்ணணுமா?
வருங்க சார், இன்னொரு ஆப்ஷன்ஸ் நான் ட்ரை பண்ணேன் சார். மோஸ்ட் ஆஃப் ஆல் நான் போகிறேங்க சார். ஜஸ்ட் அப்படியே இருங்க சார், அதில் வருதான்னு பாருங்கள் சார்.
ಏನೋ ಮಾಡಿಲ್ಲ ಸರ್. ಇದು ನೋಡು
சொல்லுங்க சார்.
இல்லை ஸ்க்ரீனில் இருக்கிறது வந்து அந்த இது ஒன்று மட்டும் தான் வருது. அந்த மற்ற ரெண்டு ஓப்பன் பண்ணிக்கிறது வந்து வரமாட்டேங்குது. நான் வந்து ஐ ஹேவ் பிபிடி ஆல்சோ வித் மீ.
ஓகே சார்.
வந்துட்டு பிடிஎஃப் ஃபைலும் ஆல்சோ ஐ ஹேவ் இட் மினிமைஸில் போட்டிருக்கேன் நான்.
ஓகே சார்.
ஓப்பன் பண்ணணுமா சார் இது?
அதை ஓப்பன் பண்ணுங்க சார். நீங்கள் எது ப்ரெசென்ட் பண்ணுங்க அதை ஓப்பன் பண்ணுங்க சார்.
ஓகே, நான் ஓப்பன் பண்ணிட்டேன் நான். என்டர் ஸ்க்ரீன் இந்த ஒரு ஸ்க்ரீன் மட்டும்தான் வருது. அதனால தான் வந்து ஐ எம் நாட் ஷூர். நார்மலாக வந்து அதர் ஸ்க்ரீன்ஸ் ஓப்பன் பண்ணி அதுவும் வரும். தென் ஐ யூஸ் டு கிளிக் இட் அண்ட் தென் ஐ வில் கிளிக் அண்ட் தென் ஷேர் ஆக்சுவலி.
Tell me.
Can you help me? அதுக்கப்புறம் இல்லை என்னோட இது மட்டும்தான் ஒரு இது வருது. ஷேர் யுவர் என்டர் ஸ்க்ரீனில் வந்துட்டு
ஓகே சார்.
ஜஸ்ட் வந்து இந்த ஸ்க்ரீன் இப்போ நான் கரண்ட்டாக ஓப்பன் பண்ணிருக்கு வந்துட்டு அதில் வந்து என்ன வருதுன்னா வந்து என்னுடைய அந்த என்னுடைய இது ப்ளஸ் வந்து அதர் பார்ட்டிசிபென்ட்ஸ் அவங்களுடைய இப்போ இதுதான் வருது.
ஓகே சார்.
அதனால தான் வந்துட்டு ஐ எம் நாட் ஷூர் என்ன பண்ணுறது. ஒரு நிமிஷம்.
சார் நீங்கள் யூஸ் பண்ண க்ரோமுங்களாங்க சார்? மோஸ்ட் ஆஃப் ஆல்
குரோம் தான் யூஸ் பண்ணுறேன் நான்.
குரோம், ஓகே சார். சார் உங்களுக்கு ஒரு ஆல்டர்னேட் ஐடி சொல்லுங்கள் சார். என்னோட யூசர் நேமும் பாஸ்வேர்டு கொடுக்கட்டுமாங்க சார்? நீங்கள் அப்படியே லாகின் பண்ணிட்டு என் இதில் பண்ண
அப்படியா?
என்னோட கூகுள் மீட்டோட யூசர் நேம் பாஸ்வேர்டு உங்களுக்கு அனுப்பிடுங்களா சார்?
அனுப்புங்க பார்க்கலாம்.
அனுப்பிடுங்களா சார்? ஓகே சார்.
ஏன் ஓப்பன் it used to come actually, I do not know. விண்டோல என்ன? ஓ விண்டோல வருது. ஹலோ, இப்போ இது வருதா? ஹலோ, ஒரு
ஓகே சார், ஓகே சார், ஓகே சார். இப்போ கரெக்ட் ஆயிடுச்சு.
இப்போ வருதா?
இப்போ ஓகே சார்.
ஆக்சுவலி வந்து விண்டோ ஐ ஹவ் டு ஓப்பன். ஆக்சுவலி விண்டோ பை விண்டோ யார்?
ஆமாங்க சார்.
நாட் ஸ்கிரீன் வருதா? அச்சா ठीक है. ஓகே, நான் இப்போ வருதா இல்லையா?
ஓகே சார், இப்போ கிளியர் தாங்க சார்.
Okay, 1 minute. I will just again close and then I'll come back. So yeah, you are presenting. Okay, stop presenting. 1 second. Let me come. Okay, present now. A window. Window. Suppose I click this. You can see it now. Ibarda. Hello. Hello.
No, sir.
No, sir, no presenting, sir. Previously is correct, right? Now is.
Yeah. Cancel it actually.
My.
Minor is there. I don't know. Present now. A window. I think I am not opening the window. I can close 1 second.
Sir.
Still about 1 minute.
Again type பண்ணுங்க சார். அதே மாதிரிங்க.
ஆக்சுவலாக வந்து when I click window by window, I mean previous timeல வந்து எல்லாமே வந்துச்சு விண்டோல. இப்போ வந்து வெறும் இது மட்டும் தான் வருது.
Right now is presenting, sir.
You are presenting to everyone, but that's fine. But now எது வந்து what actually I have to open?
உங்க பிரசன்டேஷனும் ஸ்டார்ட் ஓப்பன் பண்ணுங்க சார். அந்த ஃபைல் ஸ்டார்ட் பண்ணுங்க சார்.
வருதா இப்போ?
No sir, no sir.
I think I'm missing some small minor thing actually.
Previously is correct, sir.
ஆமாய்யா, ஒரு நிமிஷம். I mean, we are going back into trouble. Shalom. நான் மறுபடியும் ஸ்டார்ட் பண்றேன். ஓகே. Are you could able to hear me? Hello? Hello?
Yes, sir. Yes, sir. Yes, sir.
You could able to hear me, la?
Sir.
Yes,
Ipa whether you can able to share now, you can see this now?
no, sir. No, sir. Yes, sir. Yes, sir.
It's possible, la?
Yes, sir.
Okay. Okay. Can I maximize it? Just to tell me, is it okay now? Visible? You can see there.
Yes, sir. Yes, sir. It is
Yes,
visible,
sir.
sir.
It's visible, no?
Yes, sir.
Okay. Is it okay?
Yes, sir.
You can able to see the things, la?
Yes, sir.
Okay. All right. Now let us start maybe now.
சார் வெயிட் பண்ணுங்க சார். சார் ஹெச்ஓடி சார் வந்துடுறாங்க சார். வெயிட்
Oh,
சார்
yes,
சம்
oh, yes,
ப்ளீஸ்.
oh, yes,
ஓகே
oh, yes, oh, yes.
ஐ
Oh,
வில்
yes.
ட்ரை.
1 minute.
Dr. Gandhiya Vendhan.
சார்
Ah,
சார் ஐ am வெயிட்டிங் சார். சார் விமலா மேம் இஸ் ஜாயின் சார். வில் ஜாயின் சார்.
Okay, okay.
மேடம் ஜாயின் ஆயிட்டீங்களா மேடம்? ஓகே மேடம். ஓகே. ஆமாங்க மேம். AWS K-KPHO -JNS. ஓகே மேம். ஏதோ கிளிக் பண்ணி விட்டீங்களாம்மா?
Gandhiya Vendhan.
சார் ஐ எம் அவைலபிள் சார், வெயிட்டிங் ஃபார்.
இல்ல யூ ஆர் அவைலபிள். இல்ல மேடத்துக்கு இது லிங்க் அனுப்பிட்டீங்களா?
அனுப்பிச்சிங்க சார். அவங்க ஏதோ டெக்னிக் ப்ராப்ளம் சொல்றாங்க சார். ஐ எம் வெயிட்டிங் சார். ஆமாங்க சார்.
இல்ல நீங்க இப்போ எனக்கு அனுப்புன மாதிரியே வந்து அவங்களுக்கு ஒரு இதுல அனுப்பிட்டீங்கன்னா, வாட்ஸ்அப்ல அனுப்பிட்டீங்கன்னா அதுல இருந்து
வாட்ஸ்அப் அனுப்பிடுங்க சார், மெயிலும் போட்டுங்க சார், எல்லா டீட்டெயில்ஸும் போட்டாச்சுங்க சார்.
போட்டீங்களா?
அவங்க டெக்னிக் இஷ்யூன்னு சொல்றாங்க சார். அந்த டெக்னிக் இஷ்யூ அவங்க சைடு தாங்க சார். அவங்க எண்டில் என்ன இஷ்யூன்னு எனக்கு தெரியலைங்க சார்.
நீங்க அட்மிட் பண்ணிட்டீங்கல்ல?
ஆமாங்க சார், பண்ணிட்டுங்க சார். அவங்களுக்கு ஏதோ சம் ப்ராப்ளம் காமிக்குங்க சார்.
ஓகே.
வந்துருச்சுங்களா? ஐடி வந்துருச்சுங்களா?
Good afternoon, sir.
Hello, good afternoon.
Sir, some students are trying to join, but they are not able to join. Fail to join the meeting is written there.
Ma'am, few minutes, ma'am. I will admit to. First of all, I join, given the preference for Faisal, the director, Vimala, ma'am. So, few minutes wait, ma'am. I will admit to.
Okay, sir.
மேடம், நீங்கள் என்ன ஐடியில் வரீங்க மேடம்? சார் சொல்லுங்கள் சார். இல்லைங்க சார், நீங்கள் என்ன ஐடியில் மேடம் வராங்க சார்?
அங்கே கொஞ்சம் ப்ராப்ளம் ஒரு ஆளுக்கு வெயிட் பண்ணிட்டு ஹெச்ஓடியாகவும் நினைக்கிறேன். தெரியல யார் ஹெச்ஓடியா இல்லை வேறு யாரும் தெரியல.
ப்ரொஃபஸர் டைரக்டர் ப்ரொஃபஸர் ப்ராஜெக்ட் டைரக்டர் ப்ரொஃபஸர்.
ஓ சரி சரி.
Ma'am, joined, ma'am? Ma'am? Okay, ma'am. Thank you, ma'am. Professor, let us start. Sir, HOD, sir.
We can start, yeah.
Yeah, you can proceed. You can proceed, Dr. Gandhi.
Okay, thank you, sir. Thank you very much, sir. Good evening to all, respected Professor, Head Department of Statistics, Bharathiar University. Warm welcome to on behalf of organizer the skill development courses of Advanced in Data-Driven Statistical Application and Computation Techniques. The course during for from 12 to February 2021 to 1st February 2021. The under the project of RUSA Skill Development Center, BEICS RUSA 2.4. Once again, welcome to all. Professor and Head, Department of Statistics, Dr. Vijay sir. The right now handover session to welcome address Professor and Head, Department of Statistics, sir. Professor.
Thank you, Dr. Gandhi.
Thank you, sir.
Warm welcome to one and all present here. This is Dr. Vijay Raghavan, President and Head of the Department of Statistics. I'm immensely have the pleasure to invite you all to this special program that is being organized by the Department of Statistics with Dr. Gandhiya Vendhan as the principal investigator. It has been a wonderful experience for the department to have a series of programs that has been sanctioned by the RUSA 2.0 by sanctioning 5 different projects for the 5 of our faculty members. And for this set of projects being sanctioned by the university, first of all, I would like to thank my sincere thanks to our Honorable Vice Chancellor, Professor Kaliraj, for having given a great gesture by seeing the proposal submitted by all the faculty members. The RUSA 2.0 has taken much initiative to utilize the funds with the sanctioning of many projects to many of our faculty members of Bharathiar University. And this is the first time so many projects have been sanctioned by RUSA 2.0 with the funds sanctioned by our Honorable Vice Chancellor, and particularly for the Department of Statistics, 5 projects have been sanctioned. When we submitted the proposal, nearly 5 project proposals were submitted by our faculty members, and they were initially called for their presentation. During the time, the experts who visited for evaluating the proposals really appreciated the faculty members' effort for submitting different proposals on different topics. And at the time itself, we come to know that there is a possibility for getting all the projects that will be sanctioned by the university. And obviously, we also got that communication about a month back. And during this pandemic situation, we have been given this assignment to organize at least 30 sessions, 30 hours for each of the project by inviting our own friends, that is students of the department, research scholars, and also the students of affiliated colleges. Though they have not restricted the number, when we have invited the neighboring colleges as well as our university department, many of the students have overwhelmingly supported, and out of the 5 projects, 4 projects have already been completed. 3 have been completed already, and 1 program is being under progress. And this particular program being organized by Dr. Gandhiya Vendhan, today this session is for the inaugural as well as the special address. And I'm extremely happy that the Skill Development Director, Professor Bimala, the RUSA 2.0 coordinator, Dr. Rupa, and the nodal officer for having given us an opportunity to host this kind of event for the benefit of our students. The statistical principles and ideas are very much needed for many of our disciplines, particularly on the computational aspects. When these proposals are given with the different topics, we thought that how these projects can be implemented for the students, whether these project proposals can be utilized only for our own department students, or it should be extended for the students of other disciplines. But the RUSA coordinator as well as the Skill Development Center director, Dr. Bimla, they have come in for our help. Generously, they said that we have to invite the people from the government colleges so that ultimately the society will get benefit out of it. And for that, we wanted to extend our fullest invitation to them so that the students from the government colleges and affiliated colleges can also take part in this special program. And a response that have been received from them along with our own department students is overwhelming. And for that, I have to thank the RUSA coordinator as well as the skill development director. And today they are present here to give the felicitation address. I welcome Professor Bimala, Dr. Rupa Gunasilan, and the nodal officer Satish Kumar. I welcome you all. And of course, the special address is being proposed by Dr. Gandhiya Vendhan. The special invitee from Jawaharlal Nehru University has agreed upon to deliver the special address on support vector machines for classification and regression. And Professor Balasundram, he is since 1:45 he is waiting for delivering this special lecture in this particular occasion. I welcome you, Professor Balasundram, for having accepted our invitation, and definitely your lecture will be the eye-opener for the young minds of this department as well as the students of other affiliated institutions. Of course, our own students and students' friends from other institutions have joined here, and I wholeheartedly welcome not only on my personal behalf and also on behalf of the entire Department of Statistics. This kind of activity will be given to all the students and the research scholars of this department as well as the other departments. And the Department of Statistics, Bharathiar University, is always committed to extend their all possible help by rendering the service not only on theoretical aspects but also on application-oriented concepts. And this kind of workshops will definitely benefit not only the faculty members of this department, but also the career growth that can also be set for the students. And for that, this department, this university, and the career guidance department and the RUSA 2.0 are all committed for this. And I have to thank one and all present here, and I welcome you all for this August gathering. Thank you so much, and thanks for the given opportunity to me by Dr. Gandhiya Vendhan, and this program will be so successful, I hope. Thank you so much, and once again, I welcome you all. Thank you.
Thank you, Professor. Thank you for your supportings. Now I request Dr. A. Vimala, Director, Skill Development Center, BEICH, RUSA 2.0, BU, CBU. Right now, the session is handed out to the felicitation address to the director,
yes,
madam.
Gandhiya Vendhan, sir, I'm so happy to present for this skill development program. And especially, I would like to thank our senior professor, Dr. Vijay sir, for one who's continuously supporting for all the principal investigators in the department for taking care of the smooth conduct of the program of skill certification course. And really, it is a pleasure to thank them because 5 program attestation is carrying on during this period is a little difficult I to understand. And the way he has taken and has given a space to the faculty members for the betterment of the student skill development, really I understood. I appreciate the department for their wonderful job and all the principal investigators, whoever carried out the program and also the presently carrying of the program. And also I extend my happy welcome to our Balasubramanian sir. And Professor Vijay sir said, sir is waiting from 1:45 onwards. So sorry, sir, because they said 2
joined only
o'clock.
at 2 o'clock. Yes.
And unfortunately, suddenly, this is the first time I'm facing a problem, unable to join in the link. Maximum time I'll be joining on time. So that was the issue. I'm so sorry for the Professor Subramanian sir. And this will be such a kind of wonderful program. In the university, it is going on 38 programs going on like that. Almost many program is completed. And our professor, Dr. Vijay sir said it is a 30 hours program, exactly 30 hours planned according to the qualification pack. Definitely they can provide the job role to the particular program also. The support vector machine for classification and regression, whatever the things are is taken, and the statistical and computation application for the statistical work, that is also they can be planned one job role according to the national skill qualification pack. So on the basis only, the skill development center has given a framework to the principal investigators to go ahead the 30 hours program. So that is why we are given that it is not supposed to be simply right the participation of the program, or it is not a seminar, it is not a workshop. It is an exactly skill certification program. So what is happening on offline, the same thing is happening in online. If possible, we can also go for the assessment of the sector skill in future. So on the basis only, we have been prepared for that. And I wholeheartedly appreciate the principal investigator Gandhiya Vendhan for us taking this kind of program. And definitely this will be very much useful for the students community. The students is keep on getting, from the past 1 month, they are getting 5 certificate in the department. My dear student, don't think it is a simply you're getting the certificate. Definitely this will be 100% useful in your career if you're rightly using this opportunity. Because during the pandemic, whenever I'm getting any job opportunity, I mean the request from the companies, they are all keenly asking. Recently also one company has come forward and they are asking the students, they need particularly in chemistry for the particular work. They haven't asked, they are asking MSc chemistry or BSc chemistry, but they have quoted, ma'am, this skill students we needed. If the student is possessing this certificate, ask them to contact me immediately for the research work, monthly salary 40 and above. So like that only nowadays we are getting. Even I got recently one mail from Tata Consultancy for the passed out students to work the back end operation, those who are specialized in logistics and finance. So my dear students, understand that today it is going on in this specific field sometime, not for a common field. So student with a statistic student with certain kind of skills, definitely it will be more useful while you're going for a job. So this is a way you should understand and acquire a skill. And the SPY certification program in the statistics department, it is really good record and history in the department to take care of the, that is another work in the future. So with that, I happily happily congratulate the whole department and the principal investigator, Dr. Gandhiya Vendhan, for his wonderful organization. I wish you all the best to the students to take care of this work successfully. Wish you all the best to all the team members. Thank you so much for your wonderful opportunity. Thank you.
Thank you, ma'am. Thank you for supporting moral supporting different funding source and the different ways of our department, ma'am. Thank you, ma'am.
Thank you.
Thank you, madam.
Thank you, sir. Thank you so much.
Thank you so much.
Thank you.
Sir, now I request to Professor. Sir, Hajur, sir.
Yeah,
hello.
you can
Yeah.
you can invite Professor Balasundaram sir.
Okay.
So special address should be given by him.
Okay, sir.
Okay.
Thank you, sir. So warm welcome to Professor Dr. Balasundaram sir, Professor,
Thank you.
School of Computer and System Science, Jawaharlal Nehru University, New Delhi. Sir, Ph.D. got from Indian Institute of Technology, Delhi. Also, postdoctoral fellow from France. Sir is joined assistant professor during 1986 to 1990. Associate professor 1991 to 2000. After 2001 to present, still day professor from JNU, Jawaharlal Nehru University. Sir is a specialization super vector machines and extreme learning, machine methods, fuzzy regression, and applied automations and latest versions.
Okay, can I start now?
Yes, sir. Now I request to Professor the given the special address to skill development course, sir.
Okay,
Thank you, sir.
Okay, thank you really very much. And first of all, I would like to, wish all the participants very, good afternoon to everybody. In fact, I would like to, thank Professor Vijayaraghavan and then Professor Vimala and then, Gandhiya Vendhan for, inviting me to give this particular talk. Actually, as Gandhiya Vendhan has said that, I did my PhD from today, and then afterwards I went for postdoc, in Paris. This institute is called the INRIA. And then after that, I spent there for 2 years, and then I joined the JNU actually. Okay. And in fact, in this is the topic which I'm going to talk about today. So this is, support vector machines for classification and regression. So this is basically, it's a machine learning technique, and currently this is the state of the art machine learning technique applied, widely in all, in almost all real world, problems of importance and interest in the industry. So basically, it is it's also very relevant to statistics, because this particular topic is in fact, initiated from the statistical department. From Professor Vapnik. So they have, in fact, statistical learning theory they have developed, and from that particular one, then people are, started working on it. Of course, I am not a very good in statistics, and but I have some knowledge of, mathematics. So I just, work on the mathematical issues in developing the, algorithms for support vector machines, and trying to the model of SVM, which is support vector machines to. There are a lot, actually, in fact, there are a lot of variants of support vector machines are available nowadays, suggested by the experts and the researchers in this particular field. And so I am also working, as one of the, researcher in this particular direction. And I have in my lab, we have around, we produced about 7 students, because I started this particular topic. It's only in 2000, it's in 2000 only I have started actually. In fact, I started a little earlier, but then I went for abroad for 2 years, and then, I came back, and then my deanship I was working for my deanship, so I could not concentrate much on that time. So I really speaking, in the last 10 years, I'm working on this particular subject. I suppose that you could able to hear me, and then, you can able to see also the slides, I suppose. Is it okay, all of you? Hello? Hello? Hello?
Professor is visible, Professor.
Yeah, it's visible and everybody can see it, right?
Yes, sir.
Yes,
Everybody
Professor.
can watch me also. Able to hear me properly, right?
Yes.
Yeah, okay. So this particular, you know, I mean, the topic, as I stated that, you know, I mean, the last 10 years, actually, you know, I mean, very seriously, you know, we are working on this particular one, and we have around 6-7 page students we completed, and currently, you know, I have 2 students with me actually. Okay, now let me, you know, I mean, come to, you know, I mean, this particular, you know, let us start now our, you know, I just to try to give you you know, I mean, a mathematical introduction to SVM. So first I will talk about, you know, for classification, and then I will come for, you know, I mean, the question type of problems. And of course, you know, I mean, basically what we have is that we have a set of data. And then, you know, I mean, from the set of data, we are looking for some, you know, knowledge from that particular, you know, the data. And the problem associated to, you know, what we are, you know, I mean, looking for from the data, whether it is we are looking for a classification type of result, whether we are looking for, or whether we are looking for a regression type of result we are looking for. So it depends on that, you know, I mean, you know, the SVM is model is going to be, you know, different actually. Okay, I'll just, you know, I mean, move to the, you know, the next one. Okay, just a second. So I'll just take that. Is it okay? No, you can be able to see the slides, right?
Yes.
Yeah, this is fine. Hello.
Yes.
Professor,
Yeah.
only for first slide, Professor.
Yeah, this is the first slide. Yeah. Okay. Now can
Okay.
you? Okay. Now this is okay. Now is it okay now? I mean, you can see me, right? Okay. You can see the
Okay,
second slide now. Is it okay?
Not streaming, Professor.
You can see the background. The second slide. You can see me now.
No, Professor. Still is standing, Professor.
Standing.
Yeah.
God, 1 second.
Not dynamic. He's right now. He's second.
Now it's okay. Huh?
No, now it's okay, Professor.
I see. Okay. I do not know what was the issue. Again, same problem. Okay. Well, anyway, I think let us, you know, I mean, go ahead. All right. So actually, in this particular talk, you know, I mean, a little bit of, you know, I mean, the background, and then what is, you know, I mean, the type of problem which we are basically looking for. So that as a background, I mean, I will a little bit briefly talk about, and then we move on to the notations. And then, you know, I mean, I go for what's, you know, a binary classification of a data by a hyperplane. I try to explain what is this. This is a simple, you know, I mean, example. And then I will come to, you know, I mean, what we are going to do, you know, in the SVM. So how we are basically, you know, developing the algorithm for, you know, with the data actually. And there are 2 things. One is that, you know, linear model. So we always start with, you know, I mean, the simple case, which is the linear model. And then we come to, you know, I mean, nonlinear model. The interesting point with SVM is that, you know, I mean, you can do for a linear SVM, I mean, which means that, you know, I mean, you can do as linear, you know, problem. And for nonlinear model, if you want, also it's possible that, you know, I mean, you can go for nonlinear. The same thing is also true with the regression problem. Okay. All right. Now let's, you know, go to next one. Oh, sorry. Okay. First of all, you know, I mean, what is, you know, I mean, machine learning? What actually, I mean, we are going in. So we have basically, as I stated, that, you know, I mean, we have a set of data with us. So basically, once I say that you have a data with me, so which means that obviously that, you know, I mean, statistics is always there. As I stated that, you know, I mean, I'm not going for, you know, the statistical issues. So, I mean, what I'm kind to now simply looking for what actually, I mean, we are going to do it. I mean, what is machine learning? Machine learning is that where when you have, you know, I mean, your data is given, and certainly that, you know, I mean, the data contains some kind of, you know, I mean, your knowledge. And what we actually, I mean, you know, we are understood to extract some, you know, I mean, knowledge from that particular data so that we can further, you know, I mean, do some analysis on this particular, you know, I mean, whatever knowledge we got it, and then look for some simulation, and then trying to use this particular simulation, and then come up with, you know, I mean, a model, which is a prediction model actually. So, so that's what, you know, I mean, basically, you know, I mean, we are, you know, I mean, looking for. So So one or two simple examples, we can think of is that, suppose that you have, medical data with me, and our problem is that, whether we wanted to make a decision with this particular data, whether we can come up with some kind of, knowledge, and then, that particular one is basically a kind of, a decision, from that particular knowledge, whether we can come up with, some kind of a decision. And then look for, a new data comes, then I wanted to see that whether that I can apply it for, I can apply my model on that particular, when the new data is coming, and I apply my model on the new data. And then I just to see that whether what is the result of that particular, data. Like, cancer patient, suppose, I have, let's suppose that 1,000 number of cancer patients data is with me. Whether, the patient has, a cancer, suppose a brain cancer or not. So you have, a set of data with me. The data is consisting of, both, patients who are suffering from brain cancer, as well as the patients which are normal patients with respect to, brain cancer. So we have a mixture of this particular, the data, and this we take, suppose that I have 1,000 number of data, such data with me. Then what actually, we are going to come up with that, we are going to come up with some kind of a learning algorithm using this particular data. Now the learning algorithm will come up with, a decision function ultimately. And then what actually, I will do is that when you now, a new patient is supposed, coming, I wanted to see that, without consulting a doctor, I wanted to just check that whether this particular patient is suffering from a brain cancer or not. So this is a kind of, the problem basically. So you have, a collection of data. The data is a mixture of both, patients who are having the brain cancer and the patients who are normal patients. Okay? And then what actually we are going to come up with out of from this particular data, we apply some machine learning algorithms or techniques, and then we come up with a decision function actually. And the decision function is that the new data, you give it as an input to this particular decision function. The decision function will say that without consulting the doctor anything, it already had some kind of a decision function I stated. So using that particular decision function, the new data, when you feed it as to this input, the decision function will now say that yes, this particular patient is a normal patient, or whether he is, a cancer patient. Now, obviously, the question is that, how good my prediction accuracy is going to be achieved, right? Okay. So, a patient is coming, and then, it's corresponding, the medical report is with me, and I have already come up with an algorithm, and I have come up with a decision function. This particular, the patient data, I feed it into my, decision function, and the decision function now suppose it says that he is a cancer patient, but at the same time, I wanted to check that how good my prediction is, obviously. So what I will do is that without informing this particular result, I will take it to the expert, in the brain, cancer doctor. I will take it to him, and he will see the report, and then he will say that yes, whether the patient is a cancer patient or not. Then obviously, we are going to check the cross-checking whether what the machine has predicted, and which is exactly the same thing as what the doctor has predicted or not. So that's how we are basically going for it. If suppose that I have let's say 100 number of such tested data with me. Test data means that the data which I have not used for my earlier for extracting my decision function. So test data is a set of tested data. Let's suppose the 100 data is with me. Medical reports are of the patient's reports are with me. Now what I will do is that I will on this particular test data, I will apply my the decision function. I have the results. Then this particular test data results without showing to the doctor, I will take it the doctor, and then he will come up with his decisions. We'll compare. Suppose that the comparison is matching 80% of the time, 85% of the times, or 90% of the time, or only 35% of the times. So we'll just see that. If suppose that the machine the prediction of the machine is 85% of the time it is matching with, let's say the doctor's one, and we say that the accuracy of my prediction of the algorithm is at least for this particular case it's 85%. Okay, so this is the one Obviously, I mean, I do not want to go with, I mean, the decision function which I am generating using some algorithm, obviously. So this particular, I mean, the algorithm is good in, I mean, within codes, if suppose that, I mean, the precision accuracy is, let's say 80%, 90% or whatever. Of course. All right. So another thing is that, I mean, one of the, very, I mean, interesting problem is house loan problem. Suppose you go to the bank and then, I mean, what they ask is to tell you all, I mean, the details requested, record for, I mean, the bank. I'll just open this one file. I mean, let's see just whether it is able to, you see it, you could be able to see this. Hello? You could be able to see this page? Hello? You could be able to see this page?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, data samples, regular income, government employees.
Yes, sir.
Okay, just to see this particular one, this is one particular, I mean, data, I mean, I have taken, I have just, basically, I mean, generated myself. So I have, I mean, suppose that, I mean, like regular income is, what is the, I mean, suppose I go to the bank and then asking for a loan, then what, I mean, normally the bank manager is expected to, give the details, or I am taking them as one is regular income is one of the, I mean, criteria for regular income is the monthly regular income of, I mean, the family. And then, I mean, just to check that whether the, I mean, the regular income is, I mean, the employee, I mean, whether he's a government employee or not, I mean, the person who is applying for the loan, whether he's a government employee or not. If it is yes, then, I mean, I don't write the yes here, but instead of that, I mean, I'm writing the value as 1. Suppose that, I mean, I mean, he's not a government employee, then, I mean, maybe, I mean, I can use -1 as the value. And then what is the monthly expenditure? That is also, I mean, the manager will be asking you to fill it. And then, I mean, the number of service, I mean, you have. So that will also, I expect that, the manager will be asking you to supply that. And then whether you have any previous loan, and if you have a previous loan, then whether you are paying any EMI payment. So what is that particular one, so that is also, I mean, obviously the manager is interested to know from you. And then not only that, if you have, I mean, previous EMI payment, how many months, installments you are still, I mean, remaining to complete, I mean, the previous loan. So that is also the manager is very obviously interested. And then what is the amount loan you are asking for, and how many installments, I mean, you are asking, I mean, for. So I'm taking just, I mean, these are the various, I mean, the information which is, looked by, I mean, the bank manager. And once you fill these particular details and then give his your application to the manager will make a decision whether yes, I mean, you grant this particular applicant whether you loan or not. So I have, assuming that, I mean, I have the first, I mean, the applicant, which is X1 bar for me, I mean, X1 bold, which is written in boldface. This means that the suffix means the first applicant. And X back, I mean, X in bold is, denoting that it is one of the, I mean, that applicants details actually. Okay. So, I mean, I mean, this I have filled it. I can see that, I mean, the regular income is 1,20,000. This is the first attribute for, I mean, the first applicant. The second attribute is that government employee or not. The value is, I mean, 1, which is the going to corresponds to, I mean, the second, the attribute, I mean, value. And the third attribute value is 40,000. The fourth attribute for the, I mean, the first applicant is 12, and so on. So I'm taking 8 attributes. Okay. So every particular one applicant, now I am representing this information as a vector now. So the first, I mean, the component of the vector is, for example, for the first applicant, the first component of the vector is 1,20,000. The second, I mean, the component value is 1. The third component value is 40,000, and so on. And up to installments requested, which is the 1, 2, 3, 4, 5, 6, 7, 8. So 8 attributes I am using it.
Sir,
Yeah.
sir, the slide was stuck at a background, sir.
Sir,
The
not
third-
streaming, sir, for your slides, sir, professor. Oh, is static of position, professor. It's not dynamic of presentation for our slide, professor.
No, it is, I mean, I'm still the same slide. I mean, you could be able to see the slide now.
Yeah, background of slide, professor.
Background was
Audience.
slide. Okay. Okay, I'll just, I mean, reclick it. Okay. Is it, this is the previous slide now, the background slide, right? What you can see now? Can you see something?
0 point background, Professor.
Okay,
Slide.
okay. Okay, that's fine. Now, you can now see this.
It's
Any
standing,
new?
not dynamics, sir. Only standing, sir.
Oh, it's standing only. I see. Okay, okay. 1 second. I'll just, okay, 1 second. Is it okay now? Is it visible now?
Okay.
Please, I mean, please, tell me whether it is visible right now or no.
Professor,
No,
standing
sir,
the,
it's- yeah.
not only standing.
No, sir,
Slides
we
still
are,
the same, sir.
we are still on the background page. I think you have to change it to the slide view, right? Slide presentation view. On the bottom left-hand corner, the third option, I think.
Okay, 1 second. Let me open it up. Here, I mean, which one? I mean, I have to, you are presenting there. I mean, I have to change it or where I have to change?
So try bottom left-hand corner, third option, right? That slideshow option. I think that should work.
Slideshow option.
Yeah. You can see draw, right, on the bottom left-hand side. Above draw, there are 3 options.
With me, I have meeting details with me. And in that particular joining information is there. Attachment. Okay, I'll anyway. Okay, I mean, okay. Let's. Is at least this is visible, right? Okay. This background slide is visible. Hello.
Yes, sir.
Yes.
Background slide is visible. All right. So I mean, I think all doesn't matter. I will just I mean, what actually I mean, okay. Let me a little bit I mean, maybe I will speak in English. Without I mean too much worry about the previous I mean the slide what I'm trying to show it to you. Actually, if you go to the bank, means that then you are applying for a loan, then other than your name and the other details, what the manager is interested is basically how much is I mean the income of the house, I mean the person who is applying for the loan, okay, and then I mean he is also interested to know that whether you are a government employee or not. If you are a government employee, you put I mean you are corresponding the value as 1, and if you are a private employee, private company employee, you put the value as -1. And if you are not employed, then obviously maybe you can put it as 0. And then afterward, what are the other details? The details are like I mean whether you have previous loan, yes or no, and then whether if it is previous loan, then how much I mean the installment you are paying it, for example. And then I mean what is the other details? The other details are like I mean whether what is your house per monthly expenditure normally you spend an average. And then once you have this information, then you tell that how much you are asking for the loan, how many installments I mean you are asking to investor to repay. So this particular information is suppose that the manager is interested. So the first information is that whether I mean how much what is your monthly income. So this is the suppose a first applicant. Suppose I am the first applicant, Balasundaram. So obviously the manager is not keen on whether Balasundaram. Then he is interested is at the first. So the first attribute is or the first value is my monthly income. So that is I mean now what actually I mean I'm going to do that every particular application or applicant, this data whatever I mean the data. So this particular one he is going to represent it. We are going to represent it as a vector. Is it okay? So for I mean for example Balasundaram suppose, and that is not interested. So this is the first suppose I mean application suppose, And then, I mean, what is the attribute? The, monthly income, which is, I mean, now first attribute. Second attribute is, I mean, government employee or not. And suppose that I have 10 number of attributes, suppose like that. Okay, so the first applicant is now X vector. Okay, so X vector, the components are X11, suppose X12, etc. up to, so let's suppose, I mean, X110. Okay, so because the problem I want you to put it in mathematical, framework, so that, I mean, I can go into, I mean, the development of the algorithm, so that any particular, irrespective of whether my application is house loan application problem, or whether it is a, I mean, medical application problem, or maybe it is something else. So this general model, general mathematical model, if I can able to come up with and develop it and come up with it, the final result, then obviously, I mean, what is your problem then later on is that whatever the application, the corresponding the problem of the application, you put it in the mathematical framework, and then once you have the mathematical framework, you have put it into, then obviously, I mean, you can apply, I mean, now, because already I have the developed, I mean, the mathematical model, so you put it in that particular model, you come up with, the result, and then you interpret your corresponding the result, right? Okay. So this is, I mean, the strategy. So for that, I mean, now any particular applicant house loan application case, the problem of house loan case, one particular applicant is, I mean, the details are, first applicant details is X11, the attribute value is X11, the second attribute value is X12, etc. Suppose I have a 10 number of attributes, then X first, suffix name, the first subscript 1 denotes, I mean, the first applicant, the second subscript 10, it denotes that, this is the 10th attribute. So suppose that I have, I mean, this is for the first applicant, the second applicant, I have X2 is the second applicant, and the details are X21 corresponding to, this monthly, I mean, salary, X22 corresponding whether he is, for the second applicant, whether he is a government employee or not. If it is yes, then the value is 1. If he is, private employee, company employee, then the value is -1, and so on. So in this particular way, also I have 10 number of attribute values are associated to the second applicant. So suppose that I have in this particular manner 1000 number of, I mean, I have applications limit. So now I have nothing to do with, I mean, housing loan. I have the first, I mean, data is X1 vector. The second data is X2 vector. The third data is X3 vector. And I have, suppose, if I assume the 1000 number of, data. So I have the 1000, the data for the 1000, I mean, applicant is X1000. So vector, this is the corresponding the data, input from it. Okay, so now this is what actually, I mean, we are going to first of all, I mean, take this particular, I mean, the problem. All right, so this is one type of, I mean, the loan is one type of, I mean, the problem which we are going to, as I already stated that the data, I mean, I have first applicant, I have, 10 number of, I mean, attribute values. Now, initially, these applications are going to the manager. The manager is scrutinizing these applications one by one, and then he is putting his decision. So first, for the first applicant, X1 vector, the corresponding the decision by, I mean, the manager is, suppose loan is granted, then the decision value is +1. If suppose that, okay, now the second applicant, okay, X2 vector, this is the details. And what is the manager decision? The manager decision is we are going to denote it as Y2. And what is the corresponding the value? The value is going to be either +1 or -1. So +1 means that the second applicant has been granted the loan. And if it is the value is -1, then the manager has rejected this particular application. Right? Okay. So we have in this particular manner, first of all, the data set is ready for us. So what is the data set? The data set is X1 vector, X2 vector, X3 vector, etc. X1000 vector. So 1000 number of vectors. And what is the decision by the manager? The decision manager is Y1 for the corresponding to the first data X1, Y2 the decision value and corresponding to I mean to the second applicant X2. And what is the value of Y2? Y2 it can take either +1 value or -1 value, depends on what is the value the manager has assigned. But this particular data is with me. With this particular data, our problem is that whether can I come up with some kind of a mathematical model or a decision function actually, so that this decision function I can use it for any unknown data is when it's coming, the data, I mean, all the details, of any new applicant with all these particular 10 number of attribute values are supposed known to feed it, I mean, into the machine now. Don't go to the, take into the manager. You feed it into the machine will tell that whether you grant him loan or not. Okay. So this is the problem what we are going interested to do. And obviously the validity of our algorithm or the method what we are doing it depends on how good we could able to predict the output, whatever we are predicting it is matching with the experts, the decision. Okay, so this is what I mean basically the problem. So this is one particular problem. The other problem is that, for example, in this case, the output is any particular tested data comes, the output is either it's going to be +1 or -1. That is granting him a loan or don't grant him. So it's a binary output actually. All right, but whereas there are some particular problems like you are interested to know what is the dollar to rupee exchange rate, let's say for tomorrow or day after tomorrow. Suppose I wanted to know that. Then in this particular case, what actually a similar set of a similar data collection samples are with me, and what you have is that every particular day I have certain information which is going to affect the dollar rupee the attribute values. So those values are known on that particular day, and what is the corresponding the dollar rupee exchange rate on that particular day for the previous last 2 years. Suppose we have the values, we can use that, we can take it. Okay. And then with this particular the data, now any for tomorrow, if suppose that what is going to be the dollar to rupee exchange rate. Suppose I wanted to know in this particular case the output result what actually we are looking for is not either +1 or -1. You grant him a loan or you do not grant him a loan. This is not the type of addition we are looking for. We are basically looking for what is the exact value output value, which is the real value we are expecting for. The output is okay, the exchange rate is 92.15 something like that. 91 rupees, $1 is 91.25, something like rupees, like that. So we are interested to know in this particular case the output is actually not a binary value 1 or -1, but we are basically looking for a real value. So this particular kind of a problem falls under what is called the regression type of problems. The first type of problem is house learning problem, which I stated. So that is called binary classification problem. Okay, so all these things this falls under what is called supervised learning. So which means that you have a set of one time you have a set of training data. For the training data, which is the house learning loan example you can always think of. So you have a set of 1,000 number of loan applications or data is with you. So this is a training data set, and the corresponding the decision by the expert by the manager is also with me. So this is the whole training set data with me, and with this particular training set we are now come up with the decision function. Okay, so and that's what so this is the output of the training data set is given known to us. So this is a supervised learning we call it, and in our case we are going for what is the classification case, and there is a regression case. I already explained what is these two are. The other unsupervised machine learning algorithms are basically it falls under what is called clustering actually. So suppose you have input set of the data, and you wanted to for example the suppose one toothpaste company, suppose that they are interested to promote their product, then they wanted to basically interested to find out that the pattern of the people liking of the patterns of the peoples of a particular kind of a product they wanted to first of all they wanted to see it. Okay, so they wanted to first of all the patterns how people they are what type of the group of people are interested in for example movie you have either I do not know who are the actors popular, Vijay or maybe Ajit or whatever that. So you wanted to because these kind of people they may be maybe, they think that, I mean, they may be liking your product. I mean, then, you may try to find out those who are the people, interested, who are the fans of, Vijay, for example. And then maybe, I mean, you can try to, attack. So basically, I mean, the social network, what basically you are looking for is that, I mean, the patterns of, group, you wanted to cluster, I mean, I mean, a group of, people, and what type of, I mean, the patterns these people, group of people, they can have, a common, and then, I mean, you can attack, I mean, to this kind of, so it's basically, it's unsupervised, and I'm not working on that, so I don't go much into it. So let us go into, I mean, our problem. So as I already stated that, I mean, we are going to, I am in this particular case, in this particular talk, I am not going to discuss about the application of superconductor machines, but basically we are interested to go into, I mean, what is the algorithm, I mean, what is, I mean, the inside, in developing this particular algorithm, how they have developed this particular algorithm. So for that, I mean, so we are already, going into the mathematical details. So as I already stated that all vectors are column vectors, I am going to assume that. This is throughout, I mean, in the SVM literature, this is what is normally followed. And I assume that, you are also scholars or teachers, so I understand that, I mean, what is the meaning of dot product of two vectors. So you suppose that, I mean, I have a vector x vector and then y vector, two vectors. And then, I mean, what is the meaning of the dot product of two vectors is nothing but summation of xi, yi, right? Okay. So this, I think I am assuming that. And I suppose E is a vector which may not be necessary. And what is the length of a vector also, I am sure that you know what is the meaning of, I mean, how to define it. So what you do is that, I mean, suppose you have a vector where whose components are x1, x2, etc. Let's suppose xn. And what you do is that you take x1 square, x2 square, etc., xn square, you take them, sum it out, you find out, I mean, the value of, I mean, summation of the squares of, each of the components. And then you take the square root of it, positive square root you take it. And that is nothing going to be the your length of the vector, or in the literature it is called norm of the vector actually. So this is one way of basically this particular one, I mean, we are going to, it's a measure actually. So what actually, I mean, we are going to, I mean, see that, I mean, how we are going to measure, I mean, the errors, I mean, when we are going to model it, I mean, I mean, you will see that, I mean, we are going to come up with, I mean, certain error terms are going to come because it's a prediction model. So when I'm going to predict it, I mean, the data, when I'm going for it, I mean, basically what we are going for is that, we are, in some sense, we are going to compute what is called the error, and then we are trying to minimize that particular error. And therefore, I mean, minimizing error means that, I have to know what is the distance I'm, what is the concept, distance concept I'm going to use it. So in that particular sense, I mean, we are using the standard Euclidean norm, or Euclidean distance I'm going to use it, which is summation of xi square and then square root of it. Yeah. Okay, now, all right, now, so coming to, I mean, the binary classification of data by means of a hyperplane. We know what is, I mean, a plane in a two-dimensional case. You all know that. You have xy plane, suppose, the usual two-dimensional case. So what is that, any particular point, you have two components, x1 component, x2 component, okay? So what is the plane equation? So some a times of x1 plus b times of x2 plus c is equal to 0. Okay, so this is normally, this is the plane equation. So in fact, I mean, in SVM or, superconductor machines, we don't take, I mean, a times of x1 plus b times of x2, where x1 corresponding to the first component of the vector, I mean, any particular point. x2 is the second component of, I mean, the y component of the, I mean, any particular point. Then a times of a1 times, okay, a times of x1 plus b times of x2 plus c is equal to 0. We all know that this is nothing but, the equation of a straight line actually in this particular case, two-dimensional case. And if you are going for a plane, I mean, then obviously every particular point it has three components: x1 component, x2 component, x3 component. So in this particular case, the plane equation is basically, ax plus by plus cz plus d is equal to 0, or a times of x1 plus b times of, I mean, x2 plus c times of x3 plus some d is equal to 0. So we are, instead of this, A, B, C, D kind of a business. So what actually, we do is, because it's ours is a general, model we are developing it. So the corresponding, instead of this A, B, C, D kind of, things, we forgot about it. So we are taking it basically, these things are, we are going to label them as W1, W2, etc., W1. So suppose that I have, a data, one particular, for example, in the bank loan case, suppose I have 10 number of attributes for one particular applicant, then we are basically going to, we are going to deal with vectors in the 10-dimensional space, right? Okay. So in the 10-dimensional space, I'm going to take it for, a plane. I'm going for. So obviously, the 2-dimensional case, you have, A and B are coming. Plus, of course, C is there. Forgot about it. So in the 3-dimensional case, you have, A, B, C, because A times X1 plus B times Y1 plus C times Z1 plus D is equal to 0. A, B, C is coming. So here, in the n-dimensional case, or which means, for example, as I stated that in the house loan case, I have, suppose, 10 number of attributes. Then, in the plane in this particular case is, I'm going to take that as W1, etc., W10 number of components. And B is called, bias. This W is used to denote this, because these are all correspond to the weight associated to the first component actually. So W1 is the weight associated to the first component. W2 is the weight associated to the second component of the vector, and so on. So Wn is the weight associated to the nth component in determining, my corresponding the plane. We don't call it as a plane in the general case. So instead of that, we call it as a hyperplane. And therefore, okay, now, so, any particular vector is, suppose you have components x1, etc., xn. So what is the equation, plane equation, or the hyperplane equation is, W1 times, x1 plus W2 times, x2, which is W1 times x1 is weight associated, W1 is nothing but the weight associated to W1, W1 is the weight associated to the component x1. And then, similarly, Wn is the weight associated to xn. So I have the equation is of, the plane equation or hyperplane equation, we, more specifically we call it as hyperplane. So its equation is W1 x1 plus W2 x2 plus etc. Wn xn plus b equal to 0. So this is what is, our hyperplane. So if I know what is the values of W1, W2, etc., Wn, and b also, suppose if I know, then the the hyperplane equation is known to us. Okay. So this is what actually, we do. And then afterwards, any vector, x vector comes, whose component is x1, etc., xn, you put it in this equation, then whether the, the point is, if it is equal to 0, then I know that this particular point is lying on the plane, and so on. Okay, now coming to, I'm taking, one simple, example, what actually, we are going to do, okay. So I just, we are assuming that we are interested in a 2-dimensional case. So 2-dimensional case means that, hyperplane is what? Hyperplane is nothing but a, because, every particular point, I have 2 components, x1 component and x2 component. And what is that, W1 x1 plus W2 x2 plus b is equal to 0. It's nothing but the equation of a straight line only. So it's a very simple case. So suppose that, so our hyperplane in this particular case is just nothing but a straight line. Okay. So W vector is W1, W2, scalar is B, and suppose, any particular point x vector has components, so let's say x1, x2. So what is the equation of hyperplane? The equation of hyperplane, suppose, equals to W1 x1 plus W2 x2 plus B is equal to 0, and this is the equation of hyperplane. If W1 is known, W2 is also known, and B is also known, then the equation of hyperplane is known. For example, the W, is vector, which is, components are W1, W2. So W1 is suppose say 0.4 and W2 is 1.0 and the B is equal to -9. Then the equation of hyperplane is nothing but 0.4 times x1 plus x2 minus 9 is equal to 0. No? So this is what, this equation of straight line, we all know that. Okay. Okay, now come to the problem. Okay, now suppose that, now come to, our classification problem. So what is that, you can always now think of, house loaning problem, loan problem. So you have first applicant is x1 vector, x2 vector is the second applicant. But in this particular, since it's it's very simple case 2-dimensional model. So every particular, x1 vector, x2 vector, etc., they have only 2 components for us. Okay. All right. Suppose that, I mean, see the graph in this picture. The picture, I mean, I have, there are certain points which are, which appear in blue color, and the other, points which are appearing in triangle shape, which is in red color. There are, other, circled, blue colored circle, the points I also denoted them. So I have, this is the input data for me, suppose. Okay. So every particular, so as I stated that we are now in the two-dimensional case, and we have, circle points, triangle points. Circle points are blue color points, triangle points are, red color points. Assume that, one class of points are the, the label, or, the decision is +1. For other set of points, other color set of points, the set of other, other color of points. So that is, as -1, and in another one is, 1. What actually I'm taking? Suppose that, red color points, I'm taking them to be, as positive points, or, which means as if the loan is granted to this particular applications. Okay. So these red color points are positive points, and the blue, star points, they are called, they are assuming that they are all negative points. There's no need that, in this particular drawing, I am taking it as +1 or -1. If you, you can very well take in and, and discuss with the, red triangle points as -1 points, and blue color points, star points as, +1 points, no problem. Whatever the discussion we are doing, it is going to be workable. Okay. So I have, a set of, red color points which are +1 points, and the blue color points which are, -1 points. Okay. Right. Okay. All right. And what is that? Now I have drawn, I have, taken this particular straight line equation, 0.4 times x1 plus x2 minus 9 is equal to 0. Now I have drawn this particular straight line also. You can see that, this particular straight line, or this particular hyperplane, which is, the terminology. So this particular straight line or a hyperplane, it divides this particular set of, or group of points, so that the straight line, one set of, group of points are completely on one side of the straight line. The red color points are completely on the other side of, the straight line. Okay, is that right? That's very clear, isn't it? So you have, blue color points, star points are lying on one side of the straight line, and the red color triangle points are completely, lying on the other side. Okay. So ultimately, what actually, we are looking for is that we are in fact looking for hyperplane, which is straight line in this case, a straight line which has this kind of, the property. So our aim is to come up with some kind of a straight line in this particular example. Similarly, when you are going for, in a general case, we are going for, as I stated that I am looking for a linear model. So what is the meaning of linear model? They are basically, if you can see that, what is that, the line which is, the equation of, the equation W transfer, 0.4 times x1 plus x2 minus 9 is equal to 0. It's basically, it's a straight line. It's a linear. And that, so in this case, our hyperplane, we are assuming, it's a linear hyperplane, we are assuming that. Okay. All right. So our model is come up with equation of a hyperplane, which is a linear, and therefore this particular, the model is a linear model. So what actually we are looking for is, we are looking for a straight line. The straight line is divides this particular, the two groups or two classes of points, so that each one of them, lies exclusively, on one side, the other on the other side. Okay, none of them comes on this side, or, red color points are completely on one side, and the star points are, the blue color star points are completely on the other side. So this is the kind of, the model that which we are looking for. Okay, now how do we do it? First of all, take, for example, you take, 8, 7. This is one particular point. Okay. What is 8? So you can see that, you have, at the bottom, I have 8 here, and then, you have 7, So 7, 8 and 7, if you can see that it is a red color point. From the picture, you can see that it's a red color point. So, and if I put it in this particular, equation of my, equation of the hyperplane or the straight line, I will see that it is showing as a positive, greater than 0 it is showing. So, for, which means that, this red color point, it's a red color point, 8,7 is a red color point. And when I substitute on this particular, equation of the hyperplane, since, the red color point is not lying on this straight line, and therefore, and at least in this particular case, it's showing a strictly positive value. And whereas, suppose I take a blue color point, let's suppose say 4,6, and then this particular 4,6 point, I put it in this equation of the hyperplane, then I will see that it is showing me a negative value. So what actually, I see that the straight line, in such a way that it divides this particular, the plane into two mutually exclusive, off planes, we call it, so that, red color points are greater than 0 points, blue color points are less than 0 points. Okay, so this particular property, I am going to use it. Suppose that, this is my straight line. I am saying that we have, a set of, red color points, positive points are given. We have given, a set of blue color points, negative cluster points are given. Suppose, we say that this is our, decision function. What is the decision function? The decision function is a hyperplane, which is 0.4 times x1 plus x2 minus 9 is equal to 0, this straight line. Suppose I said that this is my straight line. Then what is the property? First property we are seeing is that the straight line, it is completely, it is dividing the input data points into two mutually exclusive, region points. Okay. So the straight line, making them to lie in, two mutually exclusive, regions. So the input data points are lying in two mutually exclusive, regions. So the straight line has to divide first of all, this particular two classes, mutually, distinct. Okay. So that it does. And then, what actually, this particular property I want to use it. Suppose that any particular, new data points, we wanted to, go for a new application, and he is applying for a house loan, that particular problem, suppose. Then what I will do is that, we put it in this equation of the hyperplane, that is 0.4 times x1 plus x2 minus 9 equal to 0 in this particular case. If the result is greater than 0, I say that, you give him loan, which is, it is a red color point. So it has to be on the red color side. So red color points, it's a red color point, I classify it. Whereas, a point, I substitute in this equation, and suppose that, this, its value is, less than 0, suppose it's coming, which means that, it is coming on the blue color, star points, and therefore I label this particular new point as a blue star point, which means I label this particular point as a -1 class point. So this is how, basically, we are going to decide, whether a point is red class, point of red class type, or whether it is a point of blue star type, which is, +1 type or -1 type. So what is our objective? Our objective is that to find out a straight line in this particular example or a hyperplane. The hyperplane mutually divides, divides divides the set of input points, so that each of them lies mutually in an exclusive manner of, one on one side, completely on the is on the other side. This property we are expecting to hold, and then, any particular new data is coming, then you put it in this equation of this particular, my decision function. If the value is suppose coming to be greater than 0, I say that this point is a positive class, it falls on the positive side, and therefore you label it as your prediction is +1 point, grant him a loan kind of case. And if suppose that, for the data, tested data, I put it in this equation, and I will come up with, the result is negative, less than 0 is coming the output, and I say that, okay, it's a negative class point, and therefore, our decision is it's a negative class point, which is, blue star point. Okay. So this is how, we are going to do it. Now the question is that how I can find out this particular kind of, so this is what actually, I am. So before that, certain observation. So the equation of the hyperplane is W transpose xi plus b. And if the, what is the meaning of, all the positive points are lying on positive side. So, you know, I mean, yi is, you know, I mean, what is the output for yi, you know, I mean, for the initial input data points, and for any input xi, the corresponding, you know, the decision by the expert is, you know, I mean, yi, which is equal to, you know, it can be either +1 or -1, okay. But, I mean, you know, we are already assuming that, you know, I mean, for the positive points, W transpose, you know, the equation of the plane will be strictly greater than 0 will be true. And therefore, you know, I mean, if I put it, you know, I mean, the value yi, you know, multiplied both sides, the inequality does not change. Whereas if suppose that I go to the negative class point, suppose xi is an input, you know, I mean, data, which is a negative point. And since it's a negative point, and therefore, you know, I mean, the equation of the plane, you know, hyperplane, if I substitute it, I have to get, you know, I mean, less than 0, you know, inequality is going to be true. So since, I mean, this is a negative point, so yi value is, you know, corresponding to the xi, the yi is equal to -1. So substitute, you know, I mean, so I multiply this particular equation, the inequality both side by -1, then inequality will change. So whether it is a positive input or whether it is a negative, you know, I mean, input data point, then the yi times the plane equation, you know, I mean, if you substitute, you know, in the hyperplane, you know, I mean, equation, yi times of w transpose xi plus b, this will always will be greater than or equal to 0 is going to be true. Okay. So with this particular one, you know, I mean, now, you know, what is the other thing, you know, I mean, the second thing is that, so this is for, you know, I mean, the training data has to satisfy this type of a condition. And then, you know, I mean, you know, how I once suppose that, you know, I mean, with this one, I mean, you know, I could able to find out this, you know, w vector, and then the b, suppose I could be able to find out. Then afterwards, any test data comes, I'll put it, you know, in this equation as I already stated, you know, in the previous one, you know, I mean, I'll substitute in this equation, you know, I mean, w transpose x plus b, and if it is greater than 0, it falls on the positive side. If it is less than 0, it falls on the negative side. Accordingly, I label it as, you know, I mean, a positive class point or a negative class of point. So this is, you know, with this particular, you know, I mean, the introduction, we just, you know, state that what actually, I mean, we are looking for is that we are looking for, you know, I mean, a decision function, which we call it as f of x, okay, where x is an input, you know, I mean, so this is that, you know, this function, you know, this particular decision function, what it has to satisfy. So whenever, you know, I mean, the point is, you know, I mean, the data point, whenever the input data point is on the positive side, then the decision function output will be +1. When the input data point is, you know, I mean, negative, then the corresponding, you know, I mean, the decision function effort, you know, I mean, xi, this has to be equals to -1. Yeah. Okay. So what is that, you know, I mean, so any test data comes, what I will do is that I will find out, you know, I mean, w transpose x plus b. I take its sign of this particular, I will evaluate, which means that if it is, you know, if w transpose x plus b is greater than 0, then sign of w transpose x plus b is going to be 1, positive. So this, you know, it's equal to 1. And the sign of, you know, I mean, if w transpose x plus b is negative, then sign is equal to -1, and therefore this is, you know, I mean, our decision function. I suppose that, you know, I mean, we have, you know, I mean, understood what type of, you know, I mean, the problem we are looking for. Is it okay? So come to this particular case, you know, I mean, so this particular problem, you know, so I have two set of, you know, I mean, or a class of, you know, I mean, data points, where, you know, I mean, the data class of points are such that, you know, it's possible for us to separate them by means of, you know, I mean, a linear hyperplane, okay. Or, you know, in this example, you know, I mean, what I have, I'm showing it. You have, you know, I mean, cross point, and then you have, you know, I mean, red color points and then blue color points. We could be able to separate them by means of a straight line. And in this next, you know, I mean, picture, we have a third-dimensional case, and the third-dimensional case, you know, I mean, we could be able to separate them by means of a plane, so that, you know, I mean, on one side completely red color, you know, I mean, positive class of points lie, and on the other side, you know, I mean, the other class of points lie. But in general, in practice, this kind of things may not be possible. So if it is possible, then, you know, I mean, we say that the data points, you know, it's possible for us to separate them linearly. Whereas in the case of, you know, I mean, if the data points have been plotted, they are all mixed, and then, you know, it's completely in a, you know, in a random fashion it is appearing. And then obviously, you know, it's not possible for us to separate by means of, you know, hyperplane, so that one class of points completely on one side of the hyperplane, the other side, no, on the other side, the other class of points, they lie, so that's not possible. And in this case, we say that's a non-linear separable. Yeah, okay. All right. So with this particular, I mean, the one I'm assuming that, I mean, you have a set of data is given like this, xi and yi. Okay. And what actually, I mean, we are looking for is that we are just to find out an fx such that, for positive points it is +1 output, negative points -1 is output, and what actually we are looking for is good generalization. What is the meaning of good generalization? The meaning of good generalization basically it means that the prediction ability of the I mean, if I am going to use it, and that particular prediction ability has to be, it has to be good actually. So this kind of things, I mean, it will also this generalization can be, in a statistical manner, can be, modeled, and so you have to go for what is called, I mean, visit dimension theory and so on. So this all completely in statistics. So it's really interesting to, if somebody who, because I understand that many of the audience here is from statistics background, you may very much like to, go for, I mean, how to estimate this kind of, what is the meaning of, the good generalization ability, how to, first of all, be able to measure this particular generalization ability, and what is the meaning of good generalization ability, and so on. See everything in terms of statistics. Yeah, please. Anything, questions? Any questions, please?
Professor?
Is there any questions?
Professor?
I mean, if any audience have any kind of a question, then, I mean, I can answer. Otherwise, I will just go to my, the SVM, model.
Professor?
Okay. Yeah, okay. I'll proceed now. Yeah.
Professor, take some break, Professor, after join.
Okay, sure. Maybe 5 minutes you will take?
No problem, Professor. 5 to 10 minutes, take it, Professor.
Okay, sure. Okay, we'll just continue after 5 minutes. Okay, will it fine?
Yes, Professor. Yes, Professor.
Okay, fine. Thank you. Okay.
Dear participants, sorry for some technical issue of our URL side. So previously we are conducting, I several conducting the 8 of webinars. So this is not facing the first time. So next I will send one new link is there. The Google Meet ID WB-KHWJ we join new session that join. This link is exit of process. Please kindly join the new link, the URL, Google Meet URL. Okay. This is for kind information. Kindly join this link, above the link. Professor? Okay.
Even if you have any problem, you can always, stop me, no problem. I don't mind it actually.
Okay, Professor. Professor, previously I conducted webinars, so
no problem. It's possible.
This is the facing first time.
I have also talked many talks, but still, I'm also facing, it happens.
Okay.
No issue. I will meet after 5 minutes, okay?
Okay, Professor. Thank you, Professor. Thank you very much, Professor. I think please join after 10 minutes the new URL gotcha, Google Meet URL. Thank you for
Elan key tema.